Good morning or afternoon or whatever time it is. I have our first math topic of the year. As I said in the last video, chemistry is pretty math heavy, and with it being so math heavy, we do have a lot of different topics that we're going to look at that's going to utilize scientific notation and a lot of the other math topics that we have in this unit. So with the scientific notation, it is regurgitation from your past. It should be something that you've learned before, but it's been a few years. Usually it's like 6th grade or 7th grade, you would have looked at this in math class. In scientific notation, it's just a way of writing out numbers that are very large or very small in a more condensed fashion. I'm actually going to swap over to my document camera here. And as we look at this, I've just got a piece of paper to write on, and I'm just going to write down a number that is very important to chemistry. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. That is 602 with 21 zeros after it. That number you're going to write over and over and over second semester, starting in December actually, but second semester you're going to use it a lot with the math. This number, if we have a calculator like this is what we have for a class set, these little TI 30 calculators. Even a graphing calculator, your phone, whatever it is, these calculators can't even handle that many zeros. So this isn't even able to be put into your calculator to even do the math. I am not saying you're going to have to do this without a calculator. I just have to teach you how to do scientific notation first in order to trim out all of these zeros, which are called spaceholder zeros, in order to write it in a more condensed fashion. Another number kind of on the other end of the spectrum, this one is very large. The other number is very small. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. That number, there shouldn't be a space there, I apologize that, but that number is very, very, very tiny. That is a decimal place, 17 zeros, and then 282 at the end. Again, that number, you can't even use a calculator to do that math. So what we're going to do is we're going to do something called scientific notation, where we're going to get rid of the extra zeros, which are called space holders, and we're going to write it in a way that we can use it more functionally. This 6.02 times 10 to the 23rd is the same number, just in scientific notation instead. Same thing with the bottom one. We could write this as 2.82 times 10 to the negative 18th power. Now with your scientific notation in your past, they taught you how to do the conversion, but they didn't really tell you to do how the math is done or what that number means. So when we're looking at this, just to kind of dissect it down before we look at the math, as we have 6.02, this part right here that I just circled, that's called the coefficient. That coefficient has one set of rules on how we're going to write it. And then this last part down here that I just put a box around, just the 23, that little part down there is called the exponent. So we have the coefficient and we have the exponent. Your coefficient with that one set of rules is the same no matter what. Your exponent is either going to be positive or it's going to be negative based off of a different set of rules. So I'm going to flip back over to the note PowerPoint real quick. Oops, I went back one. And as we look at these different rules, we're going to figure out how do we write it, and then I'm going to do a few examples with you. I'm going to do a separate video on how to enter these into the calculator, and I'm going to show you with a few different calculators. But first, scientific notation is just a way of writing out a very large or very small number, getting rid of what's called the spaceholder zeros. They're kind of unnecessary, and it makes that number kind of unusable when it comes to the math. So with your scientific notation, again, you either have positive exponents or negative exponents. That's the only difference with those two numbers. But one of them, the exponent is positive, it makes it a large number, 143,000. Where when you have a negative 5 exponent, you end up with a very tiny number that's a decimal. So first, when we're looking at that coefficient number, nope, we're not looking at the coefficient first. Sorry, I forgot my order that I put my notes in. When we're looking at the exponent number, just the exponent, that tiny number after the times 10, it's either negative or positive. If you have a positive exponent, what that actually means in the math world, so like Mr. Feske's world, you have that number, whatever your exponent is, times 10 that many times. So if it's times 10 to the 5th power, that means you're taking your coefficient times 10, times 10, times 10 to the 5 times because it's to the 5th power. Now, if you have a negative exponent, what that means is you have to divide by 10 that many times. So if it's times 10 to the negative 5th power, you would divide by 10 5 times. So divide by 10, divide by 10, divide by 10, divide by 10. And that's why you end up with a tiny number or a decimal type number. Now the little number in your notes, it does just say little number. I tried to simplify it. That is your exponent number. But then you have your coefficient that's out front. In order to get that, you're going to take your original decimal place and you're going to move it until you have a single digit number. That's kind of the next slide. But you're going to move it over, and the coefficient is how many times you actually moved your decimal place. So with the 6-5 with all those zeros after it, they moved their decimal place from the original spot between the 6 and the 5. That moved it 7 times, so you have an exponent of 7. Now that coefficient number does need to be a number that is bigger than 1, but it's less than 10. So you have something like 1.25 times 10 to the 3rd. You have a single digit, a decimal place, and then other numbers after it possibly. If you have something like 1 million where you just have a 1, you could write the 1 and then times 10 to the whatever power it is. But in this case, we would have 1.25 times 10 to the 3rd. Underneath that, it just shows a couple examples of incorrect answers. So you have 12.5 times 10 to the 3rd power. You couldn't stop with 12.5. You'd have to move your decimal place over one more time to make it 1.25 times 10 to the 4th power. I have to turn back on the lights. They're on a timer. Sorry. With the 63, again, you couldn't stop with just 63. You'd have to move that decimal place over one more time to make it 6.3 times 10 to the 3rd power. So when we're looking at doing these examples that are in your notes, I'm going to do them on the document camera. I've got them written out on a piece of paper. So I'm going to swap over to the document camera real quick. And with this, I've got 2 different numbers here that are on your PowerPoint. This one is 3729 with 4 zeros after it. We want to write that into scientific notation. In order to write that in scientific notation, we have to figure out where is your original decimal place. Now, there's no decimal physically written here, but that decimal place is right there. It's a ghost is what I call it. It's not real math terms, I know. But I just say that it's a ghost decimal. I just wrote it down. Now, we need to move that decimal place until we have a single digit number and then a decimal place. The easiest way for me to explain how to do this is when we look at this, we read from left to right. We read that way. So as we read through these numbers from the left, the first real digit that I see is a 3. On this one, the reason why I say that is you would skip over all these zeros. The first real digit that we see is a 9. So I would have 3. I'm going to drop in a new decimal. So my coefficient number is 3.729. I get rid of all the extra zeros that are there. If I had like I'm just pretending for a second, if it was like 37029, I would still leave that 0 there, and so I would have 3.7029. There would be a 0 in between there. You can't get rid of that sandwich 0 because it's squished in between real digits, so it's acting like a real digit. Then we're going to write down times 10. Because we're taking 3.729 and multiplying it by 10, but we need to figure out how many times we needed to multiply it. So we're going to count the spaces between your original decimal and your new decimal. which is 1, 2, 3, 4, 5, 6, 7 times. You don't have to write out those little bumps. I'm just showing you what I'm doing. So we moved it 7 times, so we would have 3.729 times 10 to the 7th power. That's a positive 7 because this was a big number. I always say that if I had that many dollars in my bank account, that would be a positive thing for me. So that is a positive exponent. Big numbers, a lot of money, positive exponent. On this one, we have a decimal type number. So we have 0.0000, I think I said 4 zeros, 980. Again, we read from left to right. So as we read from left to right, the first real number that I see is a 9. So after the 9, I'm going to drop a decimal. So my first number out front is 9.80. It's always times 10. But in this case, my exponent's going to be negative. The reason why that's negative is I originally had a decimal answer, so they divided by 10, that 9.80, divided by 10, divided by 10, divided by 10, in order to get from this spot to that spot. To figure out how many spots they moved it, again, we're going to go 1, 2, 3, 4, 5 times. So 9.80 times 10 to the negative 5th power. I will tell you these two numbers are identical because that 0 at the end is still kind of a placeholder. I don't care how you write your answer for now. Once we get into something called significant figures, it will matter, but for now, it doesn't. Now on your other slide of examples, you have these two, where you have scientific notation and you have to write it in what's called standard notation. Standard notation has all the zeros, scientific notation gets rid of the extras. So with this one, we have 5.893 times 10 to the negative 6th power. This is a negative 6, so I'm dividing by 10. That means that I'm making this 5.893 smaller. So in order to make this smaller, I need to move my decimal place that direction 6 times. So when we move our decimal place over 6 times, I'm going to have to get a little scrap piece of paper here. Cheat just a second. So we have it 6 times, so we're going to go 1, 2, 3, 4, 5, 6 times, drop in my new decimal. In all of these open little holes, I'm going to write in zeros. So 0, 0, 0, 0, 0. So we have 0.00, 1, 2, 3, 4, 5. 5893. Don't forget to get rid of your old decimal place. A lot of times people will give me answers and there's 2 decimal places in there, or they're written all wonky, they don't have a decimal place here. You do need to make sure that you get rid of your original decimal place and you move it down. Now on this one, you have a positive exponent. With the positive exponent that I have here, I need to move my decimal place this way 4 times. And as I move my decimal place that way 4 times, you can do the same thing. 1, 2, 3, 4. Drop in your space holder zeros. So you end up with 40,000 for your answer. So this is a case where people would give me 2 decimal places. They would just like give me all their work. That wouldn't be correct because they didn't get rid of their original decimal. I will warn you as well. A lot of times people will put commas in their answers. Don't do that. With the commas in your answers, those can, 1, be mistaken for decimal places, and 2, they're kind of unneeded noise, especially when I'm grading things online at the beginning of the year. It's easier to just leave them without. Another tip, you could put the decimal place at the end. It's the same number either way, so I don't care. Another frequently asked question with these is like with this top one up here, people will say, well, do I need to write that 0 out front? The answer is no, you don't have to. That's an accounting 0. It's just there to keep track of your decimal place. So you can write that answer like this or like that. Either way, I don't care. But in the next video, I'm going to teach you how to use scientific notation with a few different calculators. So you will want to get your calculator handy, and we'll do those practice problems next.